Kia ora koutou, and welcome everybody, and kia ora Roland, joining us from Journey GIS. Great to have you here, Aotearoa. This morning we're going to be looking at LiDAR data and also getting our first taste of ArcGIS Pro desktop, which is last a couple of weeks ago we had a look at QGIS with Holden, and so sort of to take the next step, we're going to have a look at ArcGIS Pro. I've got a shortcut document for you, so if you want to follow along, go to Hillshade/elevation, and I'll share my screen and you'll be able to see what we're seeing as well. So just a note for today, some of the content could be a little bit technical. So the main thing is this session is being recorded. It's a taste. We'll be coming back to this topic several times. LiDAR is going to be an increasingly important data set for Aotearoa, and it'll be featuring in all kinds of different sessions in Hui over time. So let's just have a quick look through what we've got on this shortcut document here. We'll do a Google in a moment just to find a couple of graphics, which I neglected to do, just to describe what LiDAR actually is. And then mostly though, we're going to look at the derived products of LiDAR capture. So LiDAR stands for light detection and ranging, which is essentially a laser beam bouncing back and forth from a sensor very, very rapidly, creating what's called a point cloud. And we'll have a look at the best source for Aotearoa open free LiDAR data, which is OpenTopography. We'll then have a look at, to save having to process that LiDAR data, and sometimes you might want the raw LiDAR data, sometimes you might just want the elevation surface. And I was thinking this morning, an elevation surface is basically a giant chessboard. And I was also thinking of those butcher's blocks that they make out of lots of cubes of wood, and over time as they scrub it, comes down and down and creates a different interesting shape. That's essentially what a digital elevation model looks like in my head. It's kind of a very complex chessboard. We'll have a look at a really neat story map from a colleague here at Whenua that recently created on looking at what data is available, where you can get it, some case studies. A couple of samples in there. And then also, we won't go into too much into ArcGIS Pro today, but I wanted to just point out that there is a ton of resources available, and there's also, you can get a 21-day trial for free. And there used to be, and I'll remove this part because you didn't hear me say this, but for many years, I had a rolling set of the trial. So I think my Gmail, I got up to something like number 61, dwilkins61@gmail.com or something like this. Okay.
I'm going to pretend I never heard that.
Never heard that. I don't need to now, since they moved to ArcGIS Pro. So you can sign on multiple PCs with one license. Of course, the other option is you can get the personal license for about $100 a year, or the non-for-profit license, which is about $250 New Zealand a year. Or you can get friendly with another organization that may be able to add you or lend you on their account. So let's have a quick look at some of these links. The first one I want to do, though, is look for LiDAR GIS. I'm just going to Google for a picture here. I'm hoping I can find one that looks like an airplane. So let's see, what have we got here? Here's some interesting graphics. And the one that I use as an example to sort of conceptualize what this LiDAR is the example of the South American Mayan civilization about 10, 15 years ago when LiDAR first, I'm still looking for a good picture here, oh, there we go. So when LiDAR first came out, here's a few pictures. That's a really good one, actually, this one just here. When LiDAR first came out, this idea of flying in a plane with a laser beam that's essentially like a red laser pointer, except you can't see it. And it's pointing at a spinning disc. This is in my head anyway. The disc is spinning. The lasers are being shot down towards Earth, and they're rebounding and being received by a receiver. and you get multiple points coming back, and you'll see why that's important as well. As the plane is flying along, it's basically doing like a push broom, is the old term for this kind of scanning. And what it's doing is each laser beam that's bouncing back, because it's just a short laser beam, it's creating a latitude, a longitude, but also an elevation or a Z value. So raw LiDAR, as you'll see in a couple of minutes, is actually what's called a point cloud of many, many tens of millions, if not hundreds of millions, of X, Y, and Z elevation points. So remember, with the latitude, longitude, you can find any point on Earth. With a latitude, a longitude, and an elevation point, you can create a 3D point in space. And when you combine 16 million of these together, you end up with a nice looking 3D image like these. This picture here, I just want to draw your attention to this one, because this is something, one of the real important parts of LiDAR, different to an aerial photo or a satellite image. As the plane is flying along, some laser is being reflected by foliage, by particles in the air, by branches, by grass, other vegetation, and then also the soil. So it depends on how fast your plane is flying and how dense that laser data is captured. So, for example, 10 points per square meter, so about the size of a tabletop, you might get 10 or 15 points. That means the mug that's sitting on my desk, if I'm lucky, I would be able to see 2 or 3 or maybe 1 point only, showing that there was an item sitting up off the table. And it's essentially what this picture here is showing as well. So let's have a look at what does that look like in reality. So OpenTopo.org is a really neat website. It's hosted, now I can never quite remember who is paying for this, but I think it's one of the universities, or it'll say somewhere, here we go, National Science Foundation. I think it's American. And in this site is hosted all of the raw New Zealand LiDAR data that comes from the Provincial Growth Fund funded projects. So you can see there's Gisborne, BOP, Westport, there's a whole bunch of them. If we come over here to data, so this is essentially the only link that I usually click, and then I do this, I go pan, and then I zoom in. And this red layer tells me what coverage is available. So then I'll click on this one for Gisborne, and I would guess there would be a few billion points in this point cloud. So let's have a look. Enough talking, Duane. We need to go and look at something. Let's go and have a look at this location. So I'll just copy this into the chat to save you trying to find it, if I can find the chat. Here we go. So if you want to try clicking this one with me, this will open in your browser. And so what we've got here is rather quite a different looking picture than what I was expecting. This red stuff, I suspect, was either smoke or cloud particles in the air, or it could be just noise, and that was how high the plane was flying. But when we zoom in below that red stuff, which we're just going to ignore, we can see this is in the Whangarā area. So we can see that, I think this feature is called Paikea, or Paikea's Rock, something like this. Now what we can also do is we can zoom down further, and you can, hopefully you'll be able to see in just a moment that this is not a solid object. This is made, and we'll go down here, have a look at the wharenui. This is not a solid image. This is, I don't know, I would guess 16 million points, I think, from memory. So as I zoom in here, and so what I'm doing here is I'm just trying to learn how to drive with left and right clicks of the mouse. I'm trying to tilt the whananui. So you can see here, there is the empty gap where the door of the whananui is. And if I can keep trying to drive here, tilting down a bit further, you'll be able to see the tipuna paikea on top of that whananui in 3D. Okay, I'm having trouble driving here. So here's the whananui, and you can see there are a number of dots. I would guess that would be, what, 8 to 10 meters. So you can see there are a number of dots over here. So the coverage is not particularly high there, but you can see the direction as that plane was flying past, doing this kind of push broom scanning. Okay, let's come out again, and we can see here there are a number of features. Now, over on the left here, we can adjust this view. Now, in terms of creating and looking at raw LiDAR data, this is the easiest, simplest way to do it using this tool. And the way to get to this tool, let me just show you how I did this while you can continue having a tutu, is we go find data map, we come down to the area that we're interested in. Now let's see if we can find whangaraa there. Here we go. So what I did in this case is I came down here and I went select a region. I selected a box like this. So the next step is to tell it what I want it to do with this. I want it to use this point cloud. And the primary purpose here is I want to view this as a 3D point cloud browser visualization. So I tick that on. Now I can go down and I can just press whangaraa Tuesday 9:45 and put my email, press submit, and it'll go. That will take probably 10 minutes. But you can see once I go up here to my OpenTopo and create a login, point cloud jobs, I can see the ones that I've run previously. So here's the whangaraa one that I ran, must have been yesterday afternoon, or not sure what time frame that represents. And I can come in here and I can view this job. Can I open that job? Here we go. Click this one. So what I can do for those of you who are into desktop GIS is I can download the actual LAS, or the LiDAR point cloud data. You can see here this file format is 673 versus this one, which is 66. So this Z is kind of like a zipped compression. There are a whole bunch of other artifacts that I can do, including a pits filled elevation model for doing terrain analysis, such as catchments, slope, water flow, and I've asked OpenTopo to create those for me as well, which all of this is free. Oh, I should mention the reason you sign it, you would set up a login. It gives you about twice the allowance of data in terms of size, just to be fair on all the other users. And I can come back and I can look at any of these. And usually they last for a couple of days or a week or two, just depends. And it gives me a preview of what that looks like as well. Okay, so there's another example here too, which I'll just copy and put on the chat for you. And if you have any partai as we go, feel free to. Now I do have some other LiDAR videos that you can have a look at as well. But let's have a look at this example together. This one's from Bay of Plenty. This one is just off the coast. I'll show you where this job was. So what I did is I said, okay, I want to access the point clouds for Motiti Island. And I also want a 3D visualization. And so here it is here. Now this looks not that great. This is black. Okay, we'll have a tutu here. Come over here, point budget, 10 million points. Okay, so I'm going to drop that down a bit so that it goes a bit quicker. I'm going to come down here and scroll to the bottom, and I'm going to come under filters. And I'm going to just see what's available there. So you can see that each of the points is being classified into different features like vegetation, soil, or others. Kia ora, Joe. Yes, you are able to, there we go, that's what's going on here. We just want it on elevation. Yes, so all of these are recorded and available in Haere/Potama. There's about 25 recordings in there now. Okay, so here we've got the island, and you can see here, now I'm assuming these might be, I don't know, but I'm assuming they're like kiwi fruit or citrus, or if anyone knows what these orchards are, let us know. I'd be quite interested. But you can see, you can deduce just from the shape. Now what we can also do is we can fiddle with the color scheme here. It's just very, very basic stuff based on elevation. So there is no aerial photography as part of this. This is just raw X, Y, and Z points. Okay, let's flag that. Let's move on to how do we get data for use in GIS that is the raw data. So there's a link here. I'll just copy that, put that in the chat for you as well. This shows you everywhere in Aotearoa that there is elevation data available for. So if we zoom out a little, we can see here from this LINS data service, we can download processed LiDAR. So if you've got 1 billion points, then you still may want to create a map from that, but it's very difficult when it's 1 billion points. So you can convert it to an image that looks more like a chessboard or an elevation model is what they call it. And so here's the survey index. When you click on these, it gives you information about the sample size. So 10 points per square meter tells me that data is pretty good. If I find something else that's, there's another, what have we got, 5 points per square meter. So this stuff's twice as detailed. Is it twice or half again? Can never quite remember those ratio things. But so I'd expect this data to be slightly more detailed. If I click on somewhere else, what do we got here? 6 points per square meter. So that's also pretty detailed stuff. But to download it, I need to come down to the next link, which is this one here. And this gives me the raw data that I can download. So if I just put this. Question here from me about, that's a really good question actually. LiDAR taken across Aotearoa, is there any noticeable variations in the point cloud data from region to region? With point clouds, you can actually take two point clouds from 2 different time periods and put them together. And you will, of course, get different vegetative features in that, but they can be lined up and merged quite well. They also can be over distance. It can be quite accurate because you've got really reliable features that you can register the data to. But we don't need to worry about all of that because it's all done for us before it even gets processed and put online here. The data is pretty much as it comes off the aircraft. There's nothing really else much done to it, bit of processing, bit of cleaning, but that does take a lot of time and effort. Apart from the dots per square inch or dots per number of points per square meter, that's the main difference between different regions, and it really just depends on the budget, the quality of the data capture, and how much needs to be taken out to clean out and remove what's called the noise. So if we click on this link here for the data category elevation, we can see here there are a whole bunch of different files in here. Now, it can be a bit bewildering, but I want to just try and break it down. So if we go in here, we go Gisborne, 1 meter. So there are essentially 3 files that you will want to know that are here. Number 1 is the index. So if I just come over here and remove the current layers from my shopping cart, add this one. So this is not a solid blue layer, it's actually a very fine grid. So to work with this data, rather than giving us a, I'll show you, you can see here in a moment, rather than give us this huge data set. So if we add one of these, you'll see what I mean, a huge data set. So rather than have to download and process 30 gigabytes, or if I want both, it'll be 60 gigabytes. What it's done, what the data is, how the data is managed is it's broken up into very small tiles. So for any area that you want to use this data, you'll need to download some tiles and put them together. There's the index for those tiles. The second thing to know is that the digital elevation model is different to a digital surface model. Now let's see if we can find a quick picture off Mr. Google. Here we go. This is probably a good one here. Digital, this took me a while to figure out, or get straight in my head. So don't be too concerned if it takes a few goes to figure this one out. This is a really good illustration just here, I think. A digital surface model includes buildings and bushes, trees, cars, all those kind of features. A digital elevation model is just the red line through the bottom here. This is a digital terrain model, or a different kind again, but the picture is essentially telling the right story. Follow the red line, you'll see a digital surface model. So everything is surface, the water's going to run off. The second one, elevation model. It's where the buildings, trees, and things are averaged out and removed. There'll be many examples in here. So digital surface model, the blue line, up and over. Digital elevation model, or sometimes digital terrain model, is the red line through the bottom where it's averaged. So here are those two, digital elevation model and digital surface model. So if I was to download that entire data set, 60 gigabytes, I'm only interested in one small area. I'm still going to have to stitch them all back together to recreate a surface at my end. So what I've done is I have pre-downloaded some sample data for you. So this, I'll just copy this here. And now if you want to, you can have a look here, but perhaps just watch on the screen for the moment. So we're going to start up ArcGIS Pro in a moment. So I've created these pieces of data and put them online here so that you can just access them just for convenience if you're wanting to give this a go. So ArcGIS Pro. ArcGIS Pro is equivalent of QGIS. It's provided by Esri. Esri is a company kind of akin to Microsoft. So Microsoft Office, ArcGIS Pro, or Esri ArcGIS. It's part of a suite of tools. So I'm going to download the update today. What I do is I use ArcGIS Pro. It runs on my local computer, and so I can do a lot more local processing than I might with a lot of the online tools. So what I'm going to do first is create a new project. Now I can go my new project 3, and I think the best I got up to is my new project 38 or something like that, but we'll call this LiDAR demo. And this is where the data is going to be stored in my documents ArcGIS project. So I'm just going to accept the default for now. So for ArcGIS to be usable, you've got to log in with it. So although I've provided the software for you to download in here, where have I got it? just here. You can download this if you'd like. Get the link. You will need to sign up for a trial, and there's a link in the in that one-page document there for you as well. Okay, so what do we got here? This is like the workstation of doing GIS, and it's a lot like Microsoft Office. You've got tabbed tools a tab toolbar up the top here, which is what's called context sensitive. So as I change what I'm doing in the main map here, and map is just one of the different views, in the same way that Word or PowerPoint's got slide sorter view and template view and master view and then normal view. Well, this is a normal view, but there are different views. Over on the left here is your table of contents. So this is where you can turn layers on and off. And you can see I've got 2 layers by default in there, 2 layers of my base map, base pizza. Over on the right here is where the tools will appear, or the kind of the menus and the widgets that we're going to interact with. So to get started, what we need is some data. So I've downloaded some of those files to my downloads, and let's use one of these, which is the smaller ones. We'll go this one here. So what I'm going to do is just extract all of these to a folder. This is just one of these data sets. So here's the data that I downloaded from Lynn's data service. I copy that link just so that it's easy to find again. Come back to ArcGIS Pro, and now I need to add some data. So here's where I can change my base map, and here's where I add data to the map. So what I'm going to do is paste this link in here and press enter, and it's brought me directly to that location. Now in this case, I want the digital surface model. So you can see in here there are a heap of tiles. So if I grab all of them like this, I just have to resize that and go okay. It's adding all of those tiles into my map. And hopefully it's not doing something called create pyramids. So it looks to be taking its time. I may cancel this part and we'll just use one. Okay, we might just cancel that. I'm not sure. Usually it would just go boom, 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 and it would appear, but this is the way things go with GIS sometimes. Okay, while that is doing its thing, let's go in there and have a look at what this data is. So I unzipped that download folder. This is raw native as it comes from the Lynn's data service. Here we've got the TIFF. So this is the image, or what I kind of refer to as the chessboard, a grid, a metric grid, each cell representing an elevation. If we can come back here now. Here we go, it's loaded some piece anyway. Let's remove that. We'll go and we'll add, paste that link again. We'll just go in here and add the first one. Okay, maybe we'll add a couple, the second one as well. Third, we'll take the first 5 rather than all of them. Here we go. So now we've got a few tiles. So one of the difficulties with working with this data is because it's all tiled, it's applying a color map to each individual tile. Now what I can do is I can create a hillshade for each individual tile, but that's also not that useful because what I need it to be is one surface image, just one tile. So this usually takes a while. So I'm just going to do a small example here. So view, I need to go to what's called the catalog view. So this is kind of like the file manager of sorts. And so I can come in here and I can look at my project, or I can go into that folder that I have on the clipboard, and I can come in here and I can go, okay, let's have a look in here at this data. and I can go on geography to preview it. So this is a very, very quick look at using ArcGIS Pro. We're going to do a proper step-by-step for different purposes as well. But let's use this one, for example. We'll come back here. We'll go to map. I think it is the second one. So I'm going to turn all of these off till we find that, just that one. Okay, that's the one we want there. Zoom to layer. So we can kind of see in this elevation data, and if I keep zooming in, you'll see it turns into a chessboard, kind of like something out of Minecraft, which is essentially very, very similar kind of a concept. We have data with turned into blocks. But what we can do with this is we can create hillshades and other information from this elevation data. So let's go in here and have a look at, I'm going to go in here and I'm going to use raster functions in this case. Let's go and surface. Now this would be the same kind of workflow in QGIS, just a different way of finding the tools. In this case, I'm going to create a hillshade from this so that I can see what that looks like. I pick the data that I want, 0331. I go traditional and just create new layer. And so there is what's called a hillshade. It's using, let's go back in there and have a look at what this is using. It's using the surface data that we selected, a traditional hillshade, so I'll show you what a non-traditional one is, an azimuth, so the direction that the sun is shining from, the altitude, so how high in the sky the sun is shining from, and some other things we won't worry about for now. But let's change this to a multi-directional, so more than one direction. Create new layer. And here we have a different kind of hillshade. So I'm going to remove all these ones that we're not looking at the moment, just so we can get the idea of what we've got here. So the LiDAR was captured with a plane, created a point cloud. Someone very kindly processed it for us into an elevation model, or in this case, a digital surface model, trees included. We then created a hillshade, a different type of hillshade. So this one gives us a bit more detail. If we zoom in, we can kind of see what this looks like. Now, let's say we wanted to also color this by elevation, rather than just plain old white to black. So if I come in here and I go symbology, I can choose any kind of color fit that I want. There is one particular one that I usually use though. So this one here, one of these. Now if I turn off the hillshade, you'll see I've kind of got this type of color. If I turn that hillshade back on, and then if I figure out how to make this hillshade a little bit transparent, going like this, that's getting there. So now you can see we've got this kind of view of the data, which is not from an aerial photo, not from a satellite image, but we can actually add satellite imagery to this. So in my data set, if I go add data from that same location, I go back up to the folder, aerial photos, and they all should be using the same tiling system, all going well. Okay, maybe not. Here we've got some aerial photos there now. What I can do is I can take all these aerial photos, I can group them up into a group like this to make it easier to manage, not remove. Oh, did I actually press group? Here we go. Group layout, I can minimize that so there just is one item. And I come back up to appearance and I can swipe a bit transparent. So now I've got 2 or 3 layers of data here. If I turn off my hillshade, turn off the digital surface model, there's my aerial photography. I can add in my hillshade, and depending on how much transparency I apply to the image, depends on how much will come through. Let's say I wanted to know things like contours. So I can also generate contours, create contour lines. Actually, I don't think that's the right tool. Analysis, contour. No, still not the right tool. Contours. Create contours. This one. Input raster 331 TIFF. No, that one. Not the hillshade. Contour interval. Let's say every 2 meters. Just so we'll go for every 1 meter. Why not? All in. Contour type contours. Base contour 0. Go run. This will take a second or two, but what it's going to do, it's going to generate all of those contour lines that you might be familiar with from a topographic map. Very detailed, too detailed, in fact. Now, also, of course, the other thing is this is using the surface model with the trees included, so it's probably not ideal for actually generating contours. So let's remove that one and go contour interval, let's say 5. Go run. That's a little better. But you can see here through that, the Awa, through the riverbed, you can see that's the elevation contour of, let's say, what was that be? Click in there. That's the image. Turn that off, so we can click it. Here we go. So that's telling us it's either the 190th contour or it's 190 meters up. Have a look at another one, the next one down. So 185. So that's in meters. Now we can also label them, we can color them as well. So from LiDAR data, we can pull out a lot of very, very detailed information. Now we can also go into more advanced things like hydrographic modeling, which is a little bit beyond where I'm sort of comfortable with to show you for today. But what would happen if we put a barrier across here, for example? We can go in and we can edit it, and we can work out, use the software to work out how much water would fill up this area above somewhere that might be affected, for example. But that's just, there are any number of different things that you can do with this data. Just coming back to that worksheet. Here we go. There is, probably went a bit too detailed on there, but let's have a look at this map series. What can you do with LiDAR data? So you've sort of seen a taste for how far you can go with the actual data, but let's come back a few steps. This story map, which is created by a colleague at Whenua, it's a very good one. Enter. Okay, so if you want to follow along, I've put that on there. So the Provincial Growth Fund is funding a lot of this LiDAR capture. That's been administered by LINZ in partnership with the regional councils who are running the logistics for those data capture. You can see here, Northland is coming soon. It's either been captured, ETA Q3 2021, so it shouldn't be too far away. Tairāwhiti has been done and it's released and available, so everywhere in green is available. And there's some new data down here in Whanganui as well. Taranaki is coming, Waikato, Bay of Plenty, the pale yellow areas, collection and progress. Orange area here, very, very close. Same and top of the south as well. Come to the next tab. This tells you a little bit about the elevation program. But there's one feature in here I want to draw your attention to is there's the how-to guides. So we just did a little 10, 15-minute demo going through with ArcGIS. You can do a similar thing in QGIS as well. And there's a really neat couple of case studies in here, one on Waipu, one here on LiDAR and identifying path sites. So let's have a quick squiz at these. River mapping with LiDAR. There's a story here about Rotorua. Some analysis that's been done with erosion and sediment. Let's go to the next one up here. Finding the past from above. This is a really neat story, and you can see there's a couple of these slider widgets where you can see just the surface, the elevation, and then they compare it to the aerial photo. So there's kind of interesting features down here that you can detect from the air that you may not necessarily see on the ground. You can see that's a point cloud. And there's other things you can do, such as line of sight. So if you're standing on a certain elevation, how far can you see before it's blocked? And things like telecoms, Vodafone, Spark, they all use that tool to identify where to put their towers. Here is that kind of that chessboard, the elevation model, and here is the hillshade. And you can use the hillshade to visually identify these kind of features. Machine learning, a little bit about finding patterns using algorithms. Flood modeling, LiDAR is fantastic for flood modeling because it's the most detailed elevation data we have. And there's something called a bathtub model, which kind of sounds fun, but it's not really. It's essentially you're taking a model and you're putting it in an empty bath and then you're turning the tap on. And as it fills with water, it will flow and you'll be able to see where the low-lying areas. So at a certain, at 2 meter flood level, 3 meter, 5 meter, 10 meter flood level, you will get different parts of that model filling. Doesn't always take into account, and this is the other one, is coastal inundation, because of course coastal inundation is generally associated with storms, surges, and swelling. So it's not sort of just the usual bathtub fill model. But there's a story here about that as well. So there's a lot to LiDAR. There's a lot of applications for it. There are lots of different ways you can use it. So this is just one of many that we'll have on this subject, and I may do some standalone tutorials as well without putting them in the webinar format. So for those of you who are interested in using and accessing that LiDAR data, start by having a look through some of these samples, particularly the story map, but also don't be shy about having a to-do with trying the software out. Sign up for the trial, gives you 3 weeks, the first go. And there are also other ways that you can access that software as well without having to pay commercial rates. There are some lessons here as well, and the downloads are in, and there's the trial. The file downloads sometimes can be difficult to find. It can be quite a challenging process sometimes going through signing up. It's not quite the same as a Facebook or something like that, but the software is there for you to download and have a go with. Okay, so Roland's going to give us a demo of some mahi that he's been working on. I'm going to stop sharing my screen.
Cool.
And hand over to you for 20 minutes, bro.
Sweet. I'm going to start sharing my screen. How do I just share the whole screen? Because I'm going to jump around a whole lot of
just
stuff.
Down the bottom.
Right. That was awesome, Duane. LiDAR's been a really exciting topic in this industry for quite a while now. I like that you showed ArcGIS Pro. I'm just going to show everybody if this works. Can I see that? Oh, there we go. So I'm going to minimize some stuff and move me and you around because we became small. This is an ArcGIS project, ArcGIS Pro project. Cool thing about ArcGIS Pro is it's our conventional 2D map software, but it's also 3D, so we can have scene viewers. And I just wanted to walk you guys through. This is an animation, basically a video I made for my wife. She was at Duane, Aotearoa, a couple of years ago and wanted to do her pepeha as part of a presentation. She was like, "Can you make me a cool map of my maunga?" And it's like, "Oh, I can actually make you a cool video." And using ArcGIS Pro, basically down the bottom of my screen, if you can see it, there's keyframes. And just like when we've done all the tours with Google Earth and that, and we're just setting up keyframes of certain points around her maunga that ArcGIS Pro just flies through. And it's really cool. So I set up, we flew in from outer space and we basically fly to her maunga and do a whip round. And we built this video and started building an app called Maunga in a Minute. And basically that was based on any maunga you have in New Zealand. If you give us the name of it and we have coordinates, is we can generate this 1 minute fly through that takes you to your maunga from outer space and whips around it and lets everybody know where you're from. And that's all done. The biggest important layer here was actually the height source that we used. And because we're coming in from outer space, we had to use a global height source. And it's not as detailed as the stuff that's generated from LiDAR that Duane just showed. But it's a really cool project. And it's just like in 1 minute, it flies around her maunga and all that. But what I really wanted to show you guys, if you want to have a look at some of this elevation data and all those steps, is I'm going to do it this way. Jump into a web browser, any web browser, go to Google, and then type in ArcGIS Online. Now, I don't know if I'm going to get in trouble for showing you guys this, but I get ArcGIS Online. There it is, first one. Let's go to it. I'm not going to sign in. I'm not going to do anything. I'm kind of going to cheat. I'm going to search for NZ elevation. Now, my mates at Eagle Technology take all this LiDAR data and they're reproducing an elevation layer for all of New Zealand. So they're updating little bits and pieces. Some of it's used from the past, historical height data that we had for the whole country. And when we get new LiDAR, they're actually putting stuff in. So they've created this NZ elevation layer. It's Duane Bogard at Eagle's done a really, really cool job with this. So I haven't signed in. I've just searched it, NZ elevation, ArcGIS Online. Here it is. Here's all the detail about the layer, its projection, and there should be some context here around the height. So areas where 1 meter elevation data is not available, they're using an 8 meter DM. But I can jump in. Yep.
Could you copy paste that link into the chat, bro?
Yep.
Thanks.
Good idea.
And I'll grab that and put that in our document too.
Where do I find a chat now?
Just press maybe escape or it's on the toolbar next to the share.
Oh, yep. Sweet. So I'm going to pop that link in there. So you guys, and this is where you can find out the detail that Eagle are taking all this stuff and doing all the grind in the background. But the cool thing is I can open it in a scene viewer. I haven't had to sign into anything. I'm kind of just stealing Esri's technology online and having a quick look at stuff. Base map was changed. All right. So because the data is in NZTM and you can see all the base maps that Esri has available, the only ones that will actually work are the New Zealand ones. So they need to be in the same projection as the data that we're using. So if I add New Zealand imagery, change my base map to that. Now I've got access to New Zealand elevation data, which includes for places like Gisborne that we saw and Duane showed us, the updated LiDAR information to create a terrain model. And I'm going to go to this place there. If I right click, I can tilt. And like Duane, I always kind of get this wrong of how to drive these scene views. So this is that same maunga, which is my wife's, which is for those of you from Victoria, this is Orangi. But this is quite, and as we zoom in, you can see quite detailed terrain. And that's using that new LiDAR. So they've taken that LiDAR, updated the digital elevation model and made it available as part of this New Zealand elevation data set. And you can see Orangi in the foreground here and Hikurangi in the background. But it's a really cool way without having to install any software, just through a web browser, jump in and have a look at this elevation data and some of this LiDAR. And we can go to anywhere in the country. So this is a national elevation model. and at times, depending if you zoom too fast like I do, you don't see much. Just trying to find somewhere where varying levels of detail in the elevation. But sometimes it takes a while to load. But you go to places where the LiDAR hasn't been done yet, and it's not, you'll notice that it's not as great a detail, but it's a real simple way. So jump on that link that takes you to the detail about the NZ elevation data, and just click Open Scene Viewer. And you'll see some funny things like join lines between different elevation sources.
Yep.
Just like that. So it's not perfect, but it's a really quick, easy way to get in and have a look at the impacts that this LiDAR data is having and how easily we can get access to it. So whether that's through Land Online, or not Land Online, the LINS data service, and accessing stuff through there, or just simple tools like this, like scene viewers, where we can just, I just want to see it in context of, I can zoom to that maunga and pretend I'm standing on the top of it, and then rotate my view and see what I'd see around. But like Duane said, remember, this is rendering in my web browser, and my little laptop's working its guts out trying to process all of this information.
And share the
But
screen.
we get, you get a lot better understanding of the terrain somewhere when we get to look at it in 3D rather than just a top-down map. But yeah, so heaps of ways, and I hope you guys keep the recording for this, of accessing LiDAR data. What I'm going to show you is that maunga there and the final product, and how good some of the stuff you can put out of a tool like ArcGIS Pro is. Like ArcGIS Pro is easily sort of like flagship piece of software. It's the best that money can buy, sort of thing. So this is a final video of my wife's PPR, and I don't know where the sound's coming through. Can you hear that sound, Dwight?
Not yet, no. What's that little lightning thing on there?
Oh, it's in the share thing. Eh? You were sharing. Oh, share sound. There it is. Right, let's
start it over. Yeah.
And so just output, create a YouTube video.
Yeah, I can hear it now.
Cool. Add some cool music, and all of a sudden, my wife really loves me because her Peppy Heart presentation became something pretty awesome. And sharing stories about places which all of you people know is unique content. You need to understand the real world place. It's not a 2D map. It's always going to be a 3D map. This was built with the World Elevation Service from Esri, so now I can actually rebuild this with really detailed terrain using that LiDAR data that's become available.
In the Zoom, it's a little jumpy, but I'm sure it's much smoother.
I'll post a link to the YouTube video in the chat, actually.
That's very cool.
So all of that is actually based on this, there we go, this spreadsheet. So we can take a coordinate for any maunga in New Zealand, and we're working on a process of automating this and turning it into an app where we feed in a coordinate, and it then runs through whether or not we want to come from the south to view the maunga or fly from the north. And we just fly around. Duane talked about azimuth points, fly to a certain altitude, how far away we want to be from our central point, the height we're going to be above mean sea level, and the azimuth, and basically auto-generate that fly through. So we can just put a point, enter a coordinate of, say, 500 meters north by meters east and 500 meters north. And it just runs through and generates a whole list of coordinates for us, and basically we auto-generate a fly through. But I'll quickly post the link to that YouTube video, if it was a bit jumpy, into the chat. You guys can have a look at that. So ArcGIS Pro, so much detailed stuff that we can do. And with elevation data, it creates so much more. Some of the real use case studies for the use of LiDAR and continued LiDAR, the difference between elevation models and surface models. So we've done a project with surface models, so including the trees and stuff, creating really high pulse leveled LiDAR on a small scale. We get tree heights, repeating that measure in like 1 year's time. We're actually seeing the growth in trees. So we've done a project looking at how can we monitor biodiversity increase or biomass increase in forests. And some of the forestry companies are now looking at, this is how they're managing how much wood do I have in my forest and how fast is it growing, is actually just doing repeat measures of LiDAR and checking the difference between the surface model at this point in time and the surface model in a later point in time. So LiDAR is a massive, massive tool and really changed the game with the way we can do stuff.
I think it's going to be amazing when, there, and generally it's a lot of people in academia that have got the time to focus on the one task, like identifying archaeological sites and then ground truthing and training algorithm models to detect those, fortified par versus different types of par, depending on the size of the artifacts and the earthworks and the shapes and also the locations and the terrain and things like that. So there's going to be a lot of really interesting data sets come out from this information as well. Yeah,
and the involvement of AI technology, so actually getting computers to do the work for us once we teach it. Yeah. This is what this is. Go and find all of them. So amazing. Being able to do that at scale now across an entire region like Tairāwhiti is really, really cool.
Coming back to one question I think Mia asked about LiDAR across different regions, you can quite easily merge LiDAR across different sources as well. So if you've got access to someone with a drone that has and there are a few people out there that do LiDAR-based drone capture for very small areas because it's quite intensive, you can actually quite easily use two different sources of LiDAR point clouds brought together in the same space. So if you've got a 3D point cloud of a marae, you can situate it within the 3D point cloud from the regional data set or the elevation data as well. So there's going to be some interesting opportunities to join different data sets like that as well, I think, for some cool 3D views.
Yeah, and I think that LiDAR over time in some places aren't moving, but they're talking about really intensive LiDAR, talking about Earth deformation surveys and actually seeing how the planet flexes and moves. So it's really, really exciting. There's so much to done. I just saw a comment from Aroha, there's so much to be explored now and I want another lifetime.
And I guess the key thing with all of this is, for me anyway, is you have a project in mind and you be single-minded in your process of working towards achieving that project. So you want to make a 3D map of your maunga, your awa, your marae. Start with idea and then just focus the project. And then the way to do it is tutu. There's just, my entire career is based on the concept of tutu. And I kid you not, is just sitting on the couch, watching X-Files, tutoring on the laptop. Oh, that didn't work. Crash. Oh, things crashed. Never mind. What's happening? What's Fox Mulder doing? Oh, ArcGIS is up again. Just have a tutu, playing with something. Generally, because at work, you're focusing on mahi. At work, you're focusing on different mahi. But at home, just having a muck around for an hour in the evening, something like that, particularly last weekend when it was raining, just having a play, having a look on YouTube. Generally, I can't be bothered reading tutorials. I'll skim or I'll look for a keyword or something, but I'll watch someone else do it and then I'll skip through and think, oh yeah, I can do that now. I can do that now. Oh, that's how they did it. Cool. So it's not.
Go to YouTube. Go to YouTube, type in, how do I use ArcGIS Pro to do something? Search it. Somebody's made a video. There's a guy on YouTube, John Nelson, who makes some of the most beautiful maps in the world, and he's got some 1 minute. I think he's even going to move to TikTok and start doing TikToks around making maps. But yeah, go to YouTube, put in build a surface terrain model in ArcGIS Pro. There'll be a video on how to do it.
I'll look them up and put a link in there. But yeah, John Nelson, Esri.
He's a pretty cool dude.
I'm not sure if it's his job or if he's just a.
It's become his job. I know John, and he actually loves it now. He has a weekly output of he has to generate a video on doing something cool, which is really exciting for the rest of us because we get to watch them.
Yeah. Question there from Cheryl, best program for making the video. I've got a couple ideas, but what did you use, Roland?
I've got, I can't remember what it's called. I think it's Filmora from Wondershare. So I actually bought some video software, but yeah, I make a ton of tutorial videos to put on YouTube for different groups. So I had to spend money, but there's a few really good free ones.
Heaps of free ones, yeah. I guess often the thing with the free ones, they can be a little more tricky to use, or they may have different limitations. But if you look for open source, sometimes those are cool. The one that I use for a lot of my mahi is called Camtasia from a company called TechSmith, and they have a whole suite. There's a Snagit tool, and they have Camtasia, which I've used for, I think I used to use it when I was at university for doing tutorials with students there, like that was 20 years ago. So Camtasia is cheap. It's comparatively cheap compared to, you don't need Adobe. I think you can actually pay for Adobe. You get like $15 a month or $20 a month or something. But I mean, and Adobe is the professional standard. Can we rely on councils? Question here to provide information. Does LiDAR pick up data where council pipes are buried? Unfortunately, no. So first part of your question there, councils providing information. So councils will use this LiDAR to identify, for example, every tree in a district. Every standalone tree is the kind of thing that they can generate data for, creating a point data with attributes. They can also identify power poles, roads, ditches, drains, any feature that appears in the landscape. The one thing LiDAR doesn't do is it cannot go underground. So if you remember that example of going through leaves of a tree, it will reflect off the ground, but it cannot go any further. So that's the kind of part that took me a while to get clear in my head is digital elevation model is the soil, the top millimeter of soil. It cannot penetrate soil. But with a tree, with the leaves, it can go through the gaps in the leaves. It's not going through the leaves. The leaves are reflecting it. It's going through the gaps, bouncing back off the grass or those individual soil things. And also it's the depending on the thickness of the LiDAR, the density of the point cloud. The more dense, the more number of points are going to go through those leaves and give you a stronger reflection from the ground. But the only ones that will, the only technology I'm aware of that will, well, there are two. There's metal detectors. The second one is called ground penetrating radar. And you'll see them sometimes more likely on gory crime shows where they've got this kind of a lawnmower looking thing and they're pushing it along the ground, and what it's doing is it's ground penetrating radar, so it's sending the signal and it's only going, I don't know, 6 feet, 12 feet at most, not that far, but that's what they use to identify pipes. So not LiDAR, ground penetrating radar, and it is intensive and expensive too. The unit's expensive and you need a skilled operator to run it as well. But some councils, I think, might have it. Engineering companies will have it as well, like the guys who make the roads. They will use that to check before they go and, or hopefully before they go and dig up and put their pipe through a high voltage line or something like that. So, yeah, that's just a taster today in my head. It's not kind of there's it all. It was just, okay, let's do a taste of LiDAR. The Aotearoa data had just come out. I was keen to just show, hey, here's ArcGIS Pro, which is kind of the tool that Roland and I pretty much make our careers built on. But of course now it's also part of a bigger suite. And the last 2 years, 90% of my time has been based online tools. But you pick up the old ArcGIS Pro and you think, yeah, This is like my, the hammer and the saw. It's the workbench for GIS. Okay, well that's us for today. We're going a little over time, but okay, Duane. We'll just finish up with karakia. Just before I do, big mihi to Roland. Kia ora, Roland, and thank you for coming along today and sharing your cool toys, doing some of that cool stuff up there in Gizzy. There's a beautiful sunset coming behind. Or is that sunset or sunrise? Sunrise.
I actually took that photo. It's in January. If you get down to Midway Beach, you can actually, the sun rises between Tuamotu Island and the main beach. So, yeah, one of my favourite photos.